Welcome back, Focus Learners, to another explainer. Okay, today we are literally blasting off to tackle one of the absolute biggest tech bottlenecks of our time. We are taking the heaviest computing loads right off of Earth and moving them straight into the stars. Honestly, get ready because this is a massive, massive paradigm shift. So let's dive right into this. You know, we always talk about the cloud as if it's this magical, weightless thing floating above us. But let's be real. It's actually just a massive, noisy warehouse sitting in a desert somewhere, sucking up huge amounts of resources. But what if the solution to Earth's massive AI bottleneck is, well, literally looking up? Like, what if the cloud was actually finally up in the clouds? Here's our quick roadmap for today's explainer. First, the AI power crisis. Then, moving the cloud to space, engineering the orbital edge, the trillion-dollar space race, what this means for you, and finally, the final frontier. Let's get to it. Starting off with Section 1, the AI power crisis and our limits here on Earth. We absolutely cannot keep building these giant data centers on land without hitting a major brick wall when it comes to physical space and resources. Think about it. Earth-based data centers are totally dependent on our already overstressed electrical grids, right? Plus, they gulp down billions of gallons of water just to keep the servers from literally melting down. But space data centers, man, they offer such an elegant solution to this incredibly messy earthly problem. Up there, you get to naturally take advantage of the harsh vacuum of space. We're talking unlimited solar power and entirely passive vacuum cooling. Let's put a number on this. 1,700 terawatt hours. That is the projected global electricity demand for data centers by 2035. That's more than double what we need right now, and it's almost entirely driven by the insane, explosive growth of AI. Trying to build the power plants and the energy infrastructure to handle that kind of continuous load down here on Earth, yeah, that's going to be incredibly challenging, if not downright impossible. Which brings us to Section 2, moving the cloud to space and aiming for the stars. Now, this might sound like pure science fiction, but I promise you it's not. What we are looking at here is text directly from an actual, real-world FCC filing submitted by SpaceX. And notice what they're specifically asking for. Authority for unprecedented computing capacity built specifically to power advanced AI models. Right now, as we speak, they are actively laying the legal and structural groundwork for a legitimate space-based AI infrastructure. And guys, the sheer scale of this proposal is absolutely mind-blowing. Up to 1 million satellites. 1 million. They're planning to deploy this massive system in orbital shells between 500 and 2,000 kilometers in altitude. So we're not just talking about lobbing a couple of spare servers into orbit. We are talking about weaving a continuous global web of computing power right above our heads. So how do they pull this off? Section 3, engineering the orbital edge and overcoming those intense vacuum hurdles. Okay, first major hurdle, power. How in the world do you keep 1 million servers running in space without dragging up impossibly huge, heavy batteries? Well, the answer is a sun-synchronous orbit. By following the Earth's dawn and dusk line, these satellites stay bathed in almost constant sunlight. They just soak up free, uninterrupted energy directly from the sun. That completely eliminates the need to rely on heavy, crazy expensive battery cycles. It's brilliant. But then, we've got the radiation problem. Space is harsh. If a rogue high-energy particle smacks into a GPU in space, it can literally flip a 0 to a 1. That single flipped bit could completely ruin a massive AI computation. To stop that, computer architects are using 3 specific strategies. Number 1, specialized software constantly running error detection and correction. Number 2, multi-GPU redundancy. That's where you essentially compute the exact same task multiple times across different chips, just to compare the results and make sure they match. And number 3, good old-fashioned physical shielding, literally wrapping the servers in armor to block those high-energy particles from striking the chip in the first place. And finally, cooling. Look, there's no air in space, right? So traditional fans are completely useless. Instead, the system relies on something called radiative cooling. As the filing points out, this allows for passive heat dissipation directly into the freezing vacuum of space. It's a completely closed loop. This entirely bypasses the need for those billions of gallons of fresh water that terrestrial data centers burn through every single year. Moving to Section 4, the trillion-dollar space race and the insane financial stakes involved here. The financial world is already treating orbital compute not as a fun what-if, but as a definite when. Right now, in 2025, this market is sitting at around $1.2 billion. But fast forward just a bit to 2034, and projections are shooting up to $7.8 billion. That is a staggering 22.5% compound annual growth rate over that forecast period. Wall Street is definitely paying attention. So the crucial point here is that this infrastructure is already fueling some truly incredible valuations. We've got major players making moves. Google, through its Project Suncatcher, and massive AI giants like Anthropic are actively in partnership talks with SpaceX. These collaborations totally validate the whole concept of orbital data centers. Plus, they're a massive factor in bolstering SpaceX's frankly mind-boggling $2 trillion valuation goal ahead of its IPO. But what's the actual economic catalyst making all of this a reality? Simply put, it's plummeting launch costs. Just think back a decade ago. Expendable rockets cost roughly $54,000 per kilogram to launch. Today, grabbing a ride on a Falcon 9 is down to around $1,200. But SpaceX's fully reusable Starship, the target there is under $100 per kilogram to low Earth orbit. Under $100? This massive structural shift in economics is exactly what finally makes deploying multi-ton orbital compute nodes a viable business. Okay, Section 5, what this means for you and the everyday benefits we're going to see. Now, I know all this talk about orbits and gigawatts sounds like super high-level aerospace engineering, but the everyday benefits for you and me are actually incredibly tangible. By shifting these massive computing loads off-planet, we instantly take the pressure off your local electrical grids. That means way fewer brownouts and potentially lower energy costs on your monthly bill. We're also protecting your local water supply by saving the billions of gallons of fresh water that would have been evaporated by server farms. Plus, by offloading the cloud globally, folks in rural and underserved areas are going to finally get faster internet and real-time connectivity. And, zooming out a bit, it lets us accelerate major AI breakthroughs, think new medicines or climate solutions, in a way that's actually sustainable, without punishing our planet in the process. And that brings us to our last section, number 6, the final frontier, and the Kardashev's second civilization. Let's zoom out one last time because this excerpt from SpaceX's actual FCC filing is just awe-inspiring. They literally state that launching a constellation of orbital data centers is a first step toward becoming a Kardashev Type 2 civilization. Now, if you're not familiar, a Kardashev Type 2 civilization is one that is advanced enough to harness the total energy output of its host star. So, for us, our sun. This whole endeavor is about securing a multi-planetary future, guys. It's about securing enough energy to support massive AI-driven applications for billions of people, and doing it without completely stripping Earth of its resources.
Which really leaves us with this final staggering question to chew on. Are we currently witnessing the very first baby steps of a Kardashev 2 civilization? As the cost of reaching the stars absolutely plummets and our hunger for computing power just skyrockets, the answer to our biggest terrestrial problems might literally be orbiting right above our heads. So keep your eyes on the night sky, focused learners, because the future of the internet is officially leaving the planet. Thanks so much for joining me on this explainer, and I will catch you on the next one.